to Smart Software, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justin Siepen, and I'll be your host today. I'm a developer and podcast host at SmartLogic. We are a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. From the SmartLogic team today, I am joined by a special guest co-host, the Director of Development Operations, Dan Ivovich. Welcome back, Dan.
It's great to be back.
Super glad to have you back for an episode on season 2 and perhaps more to come. Our second season is themed around Elixir internals. So today we'll be talking about the inner workings of a couple of Erlang libraries, actually, that were written by our guest, Shanti Chellaram. Shanti, how are you today?
Hey, I'm doing really well, Dustin. It's been a long work day, but ready to do this.
Great. We're super duper happy to have you on. We like to start off with just a little bit of introductory information. Would you tell us a little bit about your background, the company you work at, and how you got started in the Erlang and Elixir worlds?
Yeah, so, I graduated with a CS degree back in 2010-ish. Did the big company for a while, did some small startups in the New York area for a bit. Teachers Pay Teachers is where my first professional experience with Elixir and Erlang, but I've always sort of been like a language dabbler. So I had been familiar with Elixir and Erlang before. I knew Erlang was like this really old programming language that looked really weird and had pattern matching. And I knew that Elixir was like that, except with a Ruby syntax. And now I am working at MailChimp. I actually just started this week, and yeah, that's what I've been doing.
We've actually had a MailChimp employee on the show before.
Really?
Osa Gaius. Yeah, Osa Gaius was in our lunch-isode last season, which was our number one performing episode of all time. And yeah, it was a really good episode. He's an interesting guy. So Dan, you want to kick us off with some contribution questions here?
I think one of the reasons we all love Elixir and Erlang and this community as a whole is open source. So really kind of curious, kind of what got you into contributing to open source? What was the first library that you contributed to?
Yeah, so I've been trying to think back to like what the actual very first library I contributed to was. I feel like maybe back in high school, I was like setting up some Gentoo stuff, and I might have upstreamed like a documentation fix or like a tweak to like a batch file. That might be technically my very first open source contribution. But no, I think more seriously, remember while I was at Teachers Pay Teachers in Elixir, we were working with, it was a Bugsnag library. Bugsnag has an open source SDK for Elixir, and there was a issue with the way in which Bugsnag identified whether or not lines of code were in your project or not in your project. And I upstreamed a fix or a change rather, to how it would parse out directory structure and decide whether or not a set of files was in your project or in a dependency.
Great. Yeah, I think those kind of pain points for things we're pulling in is often a starting point. Have you been influenced by any specific libraries?
Yeah, I think I did mention Timex earlier. I think Timex is just a really beautifully written library. It's very useful. It sort of varies across the landscape I've seen. There's a whole lot of variation in terms of how open projects are and how big projects are in terms of accepting contributions. I think I want to say there's a couple out there that have really deep annotations on all of their pull requests, and they have here's a great place here's a good issue to get started on. And that was definitely a really welcoming feeling thing as someone who's really new to contributing to open source. I really wish I could name a project off the top of my head that does that, but I think any project that does a little bit of work to try and make itself a little more accessible is doing well.
You mentioned Timex, and I just want to shout out the author of Timex, our friend Paul Schoenfelder, who is on an episode of the show.
Yeah, Timex is very popular. So specifically with the libraries you've worked on, are there any kind of decisions that stand out as something that you'd made that you wish you'd kind of do differently now?
Yeah, absolutely. So I think looking back on it, so there's a couple of libraries. I think there's only a handful of libraries, maybe even just one in Elixir that I've actually put out there. My Elixir library is called Publicist, and it does one really small thing. It just makes private functions public in testing and dev environment, which is really useful if you need to test your functions that are private. My biggest concern with that one, I think, is just like it took a long time for me to be comfortable enough to like actually put that out there, when I think I really wish I just like kind of banged it out, like put it out there with some documentation of how it works, and like not like agonized over making it perfect, because it definitely just sat there for months in like my private repo, not providing any value to anyone else. And sort of like kind of getting over that myself was, I'd say that's one regret I've got. And another I've got for, I think, one of the libraries that we'll talk about later is Pri-Queue, which I named a little bit as a joke. I wish I had called it something different. And yeah, I had people say, like, you're going to regret this, and I am.
Well, that's a great segue, because I'd love to hear a little bit more about Pri-Queue. What is it? What is the problem that it solves?
Yeah, so I think there's a dearth of efficient data structure libraries in the Erlang and Elixir landscapes. The fact that Elixir and Erlang are, they are immutable by default or immutable all the way through means that several of your like go-to libraries for, or go-to data structures for, priority queues, heaps, queues even, don't work. They don't work the way they used to, because pushing and popping doesn't make sense when you've only got like single linked list access or like one-way tree access. So that was the problem I saw. And I wasn't like the one who came up with the solution. There's actually a great book and research proposal by Chris Okazaki, who wrote Purely Functional Data Structures, which is a textbook that's out there, which kind of just goes through a bunch of different implementations of efficient data structures written in a way that uses no mutable pieces, which is how Erlang works. So it's a natural fit, I think.
Well, we love book recommendations here, so thank you for that. I want to ask some really like fundamental questions here. That's kind of my thing on the show. So first of all, what is a priority queue? Like, if I'm not a computer scientist, but just like a hacker, what is a priority queue?
So a priority queue is a data structure. It's a collection of objects where you can put an object in with some score, and you can insert any number of items with any number of scores, and you can remove items based off of the lowest or highest score. If it's the lowest score, it's considered a minimum priority queue. If it's a highest score, it's a maximum priority queue. But the basic idea is you have things that go in unordered and they come out ordered.
Okay, so that's a simple one. In your documentation, we pulled a term out, and I'm going to try to get this right. What is a bootstrapped skew binomial min heap?
All right. Okay. So I'm going to break all of this down.
Okay.
So a heap is almost synonymous with a queue. It's a data structure where it's a tree specifically, where rather than like a typical binary search tree where your left is smaller than your right side, the min heap ensures that a node, first off, starting off, just a tree structure, right? You have nodes, and those nodes have children. And those children have children until you get to the leaf nodes, which don't have children. And each of these nodes contains a value in addition to whether or not like it contains children. In a min heap specifically, the constraint is that if a node has children, the value in the node is smaller than the values of the children. And so kind of percolating that, like expanding that from just one node and its children to like an entire tree, the guarantee is that the top value in that tree is the smallest value in the heap. And so that's what a heap is. Oftentimes heaps and priority queues are kind of used interchangeably, and that's what that is. Now I'm going to expand that out one word. So a binomial heap is a heap that is specifically designed in a way such that like all of the children's of one node are themselves heaps. Well, this seems like kind of self-explanatory, right? Like if a node contains like a child node, then that child node is itself its own heap. But it's sort of like using that as the mental model where you can break apart the children and you can move around children very, very efficiently, as opposed to having to copy like a large number of elements in an array, which is a common way to represent a heap. So the idea with the binomial heap is you can rearrange children a little bit more efficiently. You get access to a merge function, which basically lets you combine two heaps very quickly because you're just moving the children around. Does that make sense?
I think so. I think it's actually a really good auditory explanation of it. Would really help in the situation of visuals, I think, but that's a pretty solid explanation.
Yeah, that was one of the better explanations I've heard without having to write anything down, without having to draw it. So
we got two more adjectives to go through. We can get there. So skew binary numbers. This is a little bit of a tangent first. So if you're familiar with binary numbers, right, it's zeros and ones. And the idea is with skew numbers is you could have every now and then a 2 in addition to your zeros and ones. So normally when you have a binary number and you want to increment that binary number, and that binary number has some number of digits, you have to check you have to, check the first digit, add 1 to it. Oh, if that digit was a 1, then you have to carry 1, right? And then you have to take that carry to the next digit and then see if that has to carry 1. And you have to kind of keep going down up to, in the worst case, all of the digits of the number. If you're adding the binary number 11111 to 1, then you have to check each digit and keep carrying down. Does that make sense?
I think maybe it does. And so
I mean, we're just talking about the problem of incrementing. So we're stepping away from the heap completely. We're just talking about incrementing a binary number that's some arbitrary number of digits long. And a skew binary number is basically saying that, what if we took our binary number, but we let the very last digit and only the very last digit be 2 instead of 1?
Mm-hmm.
And when you do that, you end up with a sort of skewed representation because you're it goes 0, 1, 2, and then you get 1, 1, and then you add again, and you get a 2, 0, 0 or something. The exact numbers are off the top of my head, but the idea is when you line up the numbers that way, you end up with duplicate representations for some numbers. Mm-hmm. But you also have the property that every time you add a number, it'll only carry once. You only have to check the carry operation once. And that's a really neat math trick that took me a really long time to understand. And I'm definitely not doing a great job of explaining, but I'm sure a mathematician could.
Well, so we love to get into some of these topics. You've heard the first episode of this season where we talked to Brooklyn and Zelenko about category theory.
Oh, yeah.
We love to have these conversations because you always learn something new. And I think that just by ratcheting, you eventually get to a point where you understand some of these fundamental concepts. So then the last word here is I want to hear what you mean when you say this is a bootstrapped skew binomial min heap. And then I've kind of got a follow-up question to that.
So just quickly tying it all together, I'll say that the skew part just means basically we take that same skew binary idea and we change incrementing a number to adding an item to a tree. And that, the analogs actually just work out. You have to trust me on that. The library works for what it's worth. And the bootstrap part is that we actually there's technically 2 different kinds of binary or of heap within this one heap data structure. And the secondary kind of heap is there to be lazily evaluated. The way it ends up working out is that we end up having a heap of heaps of heaps of heaps of heaps, going very nested down depending on how deep the tree itself is. And the operations on the tree understand that, they manipulate it so that they count on that property so that we can maintain our fast lookup times or fast pop times.
So let me ask you this. Is the term priority queue synonymous with this other term, which is skew binomial min heap?
I would say a skew binomial min heap is a implementation of a priority queue. So is a binary heap, which is a lot easier to write in most languages and impossible to write in Erlang. So
Got it. So, and then your README, it says that you can guarantee the big O operation cost. How do you do that?
So I guess I'm not really doing it. Chris Okazaki did it with his mathematical proofs. What you can do is you can trace the workflows, but if you follow the code paths for both inserting and merging, you'll see that there's basically one comparison operation that happens on high-level elements in the tree. And then we create a new tuple in the merge case, or we move around one element in the non-merge cases. And then for the pop operation, for the pull operation, we just have access to the root element of the tree, which has the lowest element. So you can kind of clearly see that there's just one thing happening. And that's where you get the constant time guarantees. To verify that you actually get a log n pop, or rather unfold operation, it takes a little bit more work. But if you just look at the tree structure, you'll it becomes obvious that the tree does remain relatively balanced.
Got it. And I want to ask one more question about Pri-Queue before I let Dan take some questions on your other Erlang library. But we always like to get into sort of the development process. What were the big hurdles, challenges for you writing this library? What did you learn from writing Pri-Queue? And is there anything you might do differently if you were to write it again?
Absolutely. So Pri-Queue is an example of, I'd say both of these libraries that we're going to talk about are examples of me writing this library a little bit to put this out into the world because I felt like it's lacking, but also because I don't understand this concept well enough. And it was a process of learning. And honestly, I think doing, for me at least, is just a wonderful way for me to actually learn how to make this work. And there were many evenings spent kind of banging my head against the keyboard as to why is this just working like a linked list? And why don't I really understand what the bootstrapped and skew parts of this do or mean? So I definitely understanding that, going back and forth between the book and my implementation. Chris Okazaki has a reference implementation in a variant of OCaml. And that was really, really helpful. But kind of translating that to Erlang and building the understanding of why it should work was super hard. But it was extremely rewarding. And honestly, I would highly recommend it if anyone's trying to understand an academic concept. There's nothing like just putting it into practice.
Yeah, and it's, I'm sure Dan actually understands more of what you're talking about than I do. He's a little bit more talented with the computer fundamentals, math side of things, but it is super duper good to hear someone sort of talk you through it and give you sort of the high level understanding. I think unless we have anything else to talk about on Pri-Queue, I think we can move on now.
Yeah. So you've got another open source library, Raft ERL. Could you talk about how you got started with that?
Yeah, absolutely. So I was briefly at the Recurse Center a couple of months ago, and it's not required to have a project lined up, but I did have something I wanted to do, which was I wanted to build a little distributed database. I believe in a whole lot of stuff about distributed systems, but I believe that we can do things different and better. And one of my goals for my time at the Recurse Center was to understand consensus algorithms. And there's two big ones. There's Paxos and there's Raft. And Raft is the one that is a little bit more, it's supposed to be easier to understand. And I will admit that I think reading through the paper, it is easier to understand, except where they hand wave tons of the implementation. So yeah, I decided to write my own Raft implementation in Rust, actually. And I quickly discovered that I did not want to do that. There was just a lot of unknowns around how to maintain connection state and what the actual pieces of state I wanted to maintain were. And I figured if I'm going to be doing this, I want to do it a little bit more dynamically. I want to do it in a language that I'm more comfortable with. So I decided to prototype it in Erlang. Hence, Raft Erl. That's how I pronounce it.
Okay, great. I know, I've seen several implementations of Raft. I know it tends to be something where people implement as much of it as they need to. Could you, how much of Raft have you implemented?
Yeah, so I have implemented arguably the whole thing with a bug, or arguably 2/3 of it, depending on how you look at it. There's okay. A couple of main components to Raft, but it's basically I'd say I'd split it a little bit differently than they describe in the paper. There is a protocol for many nodes to agree or disagree on a single proposal. Then there is the protocol for servers to agree on who is the leader. And then there's a protocol for servers to say, oh, hey, like check to make sure that other servers are alive. Those are the three protocols that make up Raft. And of those three, I have completed the leader election part and the heartbeat part, but I have a bug in the proposal catch-up part. So that part is not working. It is not a complete Raft algorithm without it. But I guess the other parts do function properly. I can spin up a virtual cluster in my test Erlang VM, and my nodes will detect each other. They'll decide that one of those nodes is the leader, and then they will do nothing because they have nothing to do.
Okay. So you mentioned a specific event that kind of motivated the creation of this library. Were there other kind of motivating factors? And you mentioned an interest in distributed systems. I guess what are you hoping to use this for?
I am deeply interested in this idea that you can. I guess I'm going to back up just a little bit. So I come from the space of web application development. And in web application development, there's LAMP stacks, there is MVCs, but basically you have your client computers connect to your server connects to your database, and everything's happy up until your database gets overloaded. And maybe that's like not strictly true. Maybe your application gets overloaded, so then you get more of the application, and then your database gets overloaded. So I believe strongly that there's a different and better way than just introducing a cache, which works until the cache gets overloaded. And that is that you would have a push mechanism where like your application servers themselves maintain the state, and there is no database. There is no real database. The database is just shared between your application nodes. That's like the dream. And that's what I've been working towards. That's what I was hoping I could get towards with this. I believe that this would be a fundamental building block of deciding like what server needs to serve which traffic, etc.
Okay. And so are you building this up from, Erlang fundamentals, or are there parts of the Beam that you're leveraging to accomplish some of this? Kind of where does your library start and where does the Beam end?
Yeah. So right now my library handles the on-disk persistence. I'm not sure that it does on-disk persistence, but it is leaning on Erlang's messaging capabilities. So it is relying on the Erlang distribution protocol. Theoretically, I could build my own UDP protocol and have it work just fine over that. But that's theory, and that theory is a lot of work to put into practice. Yeah, so I think for Erlang is taking care of all the hairy networking. Erlang is taking care of some of the serialization issues, so I don't have to worry about anything. I just deal with Erlang terms. But there are no other technologies at play yet. There's no other databases. There's no other tools in use. It's just my code and the Erlang VM.
Great. Is there anything else that you'd like to say about Raft Erl?
I really hope to finish this up and round it up, and then I think my next goal for this is actually I think it'd be great if somebody else had like ideas of what they wanted to do with a Raft implementation. I do want to get this library bug-free, working properly, and something that people can build upon. But after I'm done, polishing it up, I definitely want to just re-implement the same thing, but in probably C or Rust or like another low-level language.
Great.
This is great because when we first started talking about Raft ERL, you mentioned distributed systems being something that you're really passionate about. You also mentioned it before we started the podcast here. I'm curious, like, why is this occupying your mind? Why are you excited about it? What's the nature of your interest in distributed systems, and where do you think we're heading?
Yeah, so I think it all started for me back in university. We had to choose a couple of specializations, and back then it wasn't called distributed systems. Back then it was high performance computing. And back then it was less about distributing work across, a million like Raspberry Pis or whatever. It was about, I have a supercomputer, and the supercomputer has like, a million cores or something like that, or like, 700, 800 cores running in parallel. It has like a certain memory architecture. How are we going to just split up this work to function like efficiently. And these sorts of technologies are still in use. Like GPU became a thing. It's still out there, it's still very relevant. And it's the same underlying theory and principles are at work for distributed computing on the internet. It's really just a lens that needs to be applied. And I see this gap between what academic theory has and says is possible. I think there's like great work being done by like the Partisan Project to kind of address some of these issues, making these academic theories into reality. So right? Like when you've got more than one computer, you've got a distributed system, and the whole internet is a massive distributed system.
So I want to follow up on this a little bit. We are closing out on time, and I've got we're going to leave you some time to do like any final plugs or ask for the audience, that kind of thing. But I want to follow up on this because before we got into the interview, Dan and I were actually talking about like what sort of training to do at ElixirConf, and one of the trainings that's going to be at ElixirConf is around distributed systems. I'm curious, like for someone like me who say doesn't have really any experience building this, like what do you think is like a practical sort of like step that I could take to move my understanding forward, to move my skill development forward? Like, what would you tell someone who doesn't have like an academic background in the underlying computer science? What would you tell someone like me?
I would say if you just open up your Elixir REPL or your Erlang, like create a little project and try and build Gen server. Just try and build Gen server. Maybe even try and build Gen server without using like any sort of underlying thing like a cast. Just use send and receive. And I think that exercise is going to start, moving you towards this like understanding of what's possible. And I think that kind of makes the abstract ideas a little bit more real. And then beyond that, I think if you just kind of follow, maybe there's some talk of this on like Erlang mailing lists. I have to plug Partisan again. There's just really great work happening there. Yeah, I'd say that's where I would get started for just a practical purpose. Like start experimenting, try not using call, use cast, and see how far you can get with that.
Okay, that is a great call to action. You get the last word on any final plugs, asks for the audience. Where can people find you on social media? How do you want people to get involved with the work that you're doing? Anything you want, any shameless self or else promotion.
Yeah, for sure. I want to give, first off, I'm going to give a couple of thanks. Christoph Meckeljohn, just been putting out a lot of great work. I'm like deeply inspired by a lot of what he's doing. I'd say, again, Chris Okazaki, like probably a big part of how I got into all of this was I just started reading his textbook and was just obsessed. And, like shout out mom and dad. Thanks a lot. And yeah, so for shameless plugs, you can find me on Twitter, mostly just tweeting stupid memes at the C coder, like C a lot. And yeah, if you follow me on GitHub, it's Shanti. So there's 3 I's and, or Shanti 2. There's still 3 I's. And I'd love to talk with anyone. That's the best ways to reach me.
Awesome. Shanti Chellaram, thank you so much for joining us today. This has been a really interesting conversation. A lot of it was over my head, but I'm going to go back and listen again, and it gives me a lot of follow-up reading to do. Dan Ivovich, my Director of Development Operations here at Smart Logic, super glad to have you on as a guest host.
It was an absolute pleasure.
Once again, this has been Smart Software with Smart Logic. Join us next time for more conversations on Elixir internals.
Great. Thank you so much.